Today's lesson is an introduction to scale factor. So in class, we talked about what a scale factor is and how this concept can be used outside of school. So two key things it's used for is enlargements and reductions. So if you're thinking about like photographs or a recording for a movie where you have to enlarge it to fit on an IMAX screen versus a widescreen versus a TV screen. Blueprints definitely use scale factors. Also, floor plans for an apartment or a home. Also, models use scale factor, whether it's a model car or like a model of the Empire State Building. Scale factors are used, and maps. A lot of times now, Google Maps does a lot of the work for us, but you have to understand that people created the algorithms, which is the math that makes Google Maps work, and scale factors are a part of that. So, to emphasize this, if we have a model that's created, for example, of a bridge, and the math is incorrect, you could have an epic fail situation happen where the bridge doesn't even match up when you meet in the middle. Now, this is Photoshop, this is not a real event. But the key thing is when models are made and scale factors are applied and the math could be wrong, serious things can happen and a lot of money can be wasted. So to show you an incorrect enlargement, we have the original on the left and then the incorrect enlargement on the right. So when you have an enlargement, the original should just be enlarged and it should be exactly the same. So here, the horizontal distance was kept the same, but the vertical distance was doubled. So that's why it's not correct. And then the other way this could happen would be one side here that's vertical is not enlarged, but the horizontal one is. So this one's times 2, but this one stayed the same, so times 1. So when you're doing an enlargement, you have to enlarge every single side in order for the enlargement to look the same and be proportional to the original. So here, both sides had a scale factor of 2 because they were multiplied by 2. Here's an example of what you'll need to do on your worksheet. So we start off with a rectangle M and we look at the original dimensions of this rectangle. We have 4 squares by 6 squares, and we're going to do a scale factor of 2. That means we're going to take each side length and double them. So 4 times 2 would be 8, 6 times 2 will be 12, and then this side is also 4 originally, so it becomes an 8 and a 12. And then we're told what to label our new shape. In this case, we're labeling it N. So once again, started with a 4, it became an 8. Started with a 6, it became a 12. We're also going to be reducing shapes. So we're back to our original rectangle, but this time the scale factor is a half. So when we're using scale factors, we always multiply. So it's going to be 4 times a half, or half of 4, which is 2. And then 6 times a half, or half of 6, which is 3. And we continue our rectangle all around, and we're going to call this one rectangle M. So we have 4 becoming a 2 and 6 becoming a 3 for a scale of 1/2. Now you're going to be using your worksheet, so it's time for you to do some work. So we're going to look at part A first. We start with the original rectangle, which is a 2 by 4, and we're going to apply a scale factor of 2. So the top part is 2. 2 times 2 is now going to be 4 in length, and the 4 side times 2 is going to become 8 in length. And then because this is a rectangle, the opposite sides are the same length. And then it says we need to label this rectangle with a lowercase a. If you use a capital A, you're saying that this image and this image are the same, but they're not. So we're going to call our new rectangle A. Now for part B, we're going to go back to the original rectangle and we're going to apply the scale factor to this original rectangle and enlarge it over here. And the scale factor is 2.5. So think about what you did over here in order to make this one increase by a factor of 2. We do 2 times 2. So in this case, we're going to take this side length and multiply by 2.5. 2 times 2.5 is 5. So this will become 5. And then we're doing the same thing to the vertical length. 4 times 2.5 will become 10. And then this side length is also 5, and this one is 10. And we are labeling this rectangle lowercase b. The last one is going to be part C, and this time we're doing a reduction, so a scale factor of a half. So now we're doing 2 times a half, or half of 2, which is 1 square, and then 4 times a half, or half of 4, which is 2. We complete our rectangle and label it C. Now, before we go on to the next one on the worksheet, which is a irregular shape, I want to look at 2 problems. So the first problem is, if this is the original and this is the new shape, the enlargement, what is the scale factor? Well, if you're looking at the 3 has become a 15 and the 4 has become a 20, then that means, that means we've done 3 times 5 and 4 times 5. So the scale factor is 5. Now on this one, we're going from an original shape here, which is a large triangle, to a smaller shape. This is the new shape that's been reduced. And with scale factor, you have to multiply. So you can't say 12 divided by 3. That's not our scale. Because if you say the scale is 3, you're saying 12 times 3 is 4, and 12 times 3 is 36, not 4. So what could you multiply by to get the 12 to become a 4? Well, if you're unsure, you can take the new number and divide by the original. Okay, it's kind of like when we're doing y over x. So 4 over 12, and unfortunately I can't write on the PowerPoint, but 4 over 12 would simplify to 1/3. So the scale factor is 1/3. 12 times 1/3 is 4. So similar on this one, how we did times a half to get it to be smaller. On this one, we're going to do times a third to reduce it by a third. Okay, now we're on to part 2 on the worksheet. So you're going to start with the dot here, and then you're going to enlarge it starting with this dot, and the scale factor is 3. So it'd be a good idea to pause the video now and try it and then check how you did. So this side length is 2. In order to do a scale factor of 3, we have to multiply by 3. So 2 times 3, this becomes a 6. This length down here is 6 originally, so that enlarges to 18. This side length here is 3, so the enlarged side is 9. And you can check how you did, seeing how much space is left over here if you counted things right. So this only has 1 square left up here. Then the 1 becomes a 3. This 2 becomes a 6. This 3 becomes a 9. And then this 1 becomes 3. And connect here, the 2 becomes a 6. And we still need to label it with W. Okay, we're on to the back. This shape is going to be reduced by a scale factor of a half. So once again, please pause the video and hopefully try it before you see how to do it or to check your work. So this one is 10. So 10 times a half, or half of 10, is 5. And then this one here is 8. So half of 8 is 4. Now the diagonal is tricky. What I do is I go from this corner and I say, okay, to get to this point right here, so that I can just connect this part with the diagonal, I have to go down 2 and right 4 squares to get to this point. So once again, from this corner, you go down 2, and I said right, but I meant left. So sorry, left 4. So now we're going to do half of that. So instead of going down 2, left 4, we're going to go down 1, left 2, because 1 is half of 2 and 2 is half of 4. So it looks like, oops, I didn't realize I'm going to do this next. But when we get over here, this point is going to connect here. But since I, on my PowerPoint, have it going this way, I forgot. We're going to do 6, half of 6 is 3. And then now with this diagonal, so from here, you go over 2, and that's where the dot's going to be. So on here, that's down 4 squares. So here, half of that would be down 2 squares. So we're right here. And then instead of going over 2, we're going to go half the distance, which is 1. So that means the diagonal is going to go from here to here. And then this is 4. Half of 4 is 2. And don't forget to go up. But instead of going up 2, you're going to go up 1. And then you can connect these two. And we label it lowercase g. On to the last one, it tells you to enlarge this letter M using a scale factor of 2. And if you do that, you are going to get your M to look like this. And it does say shade it in when you're done. So after you've checked the dimensions of your M, please do make sure to shade it in. Now, assignment 2 is going to be the scale factor enlarged name, word, or picture homework assignment. So you're going to be using grid letters or numbers to write your first name, last name, a nickname, initials, jersey number, or school appropriate word onto the grid. There should be about 6 to 8 letters on this grid. So you'll have 3 to 4 on the top of the grid and 3 to 4 on the bottom of the grid. My example I made is it's math D to 11 because I'm a math teacher and D to 11 is my room number. So I just used the grid letters and I spelled out math D to 11. Now, the other option is to do a picture. So you could search on Google grid pixel art. Just make sure it fits in the 20 squares by 13 squares here. And the shape I found, or the picture I found, so this is, if you're looking at it, the way the paper is set up, but I'm actually going to be turning my paper vertically. This is a little grid giraffe. So if you're going to do a picture, you need to have over half the grid in your image. So this right here, it's covering over half the grid, so it looks good. Now, what you have to do is after you've designed your image or designed your words, you have to enlarge it using a scale factor of 3. So you're going to get the large paper that I have, and you're going to increase everything by a scale factor of 3. So that includes where you're starting from. So here on the little sheet, I went over 2 and down 1. So on the big sheet, because we're doing a scale factor of 3, instead, I have to do 2 times 3, which is 6 squares over, and then 1 times 3, 3 squares down. So that's why I started here on the big paper. So this is the large paper. And then it's 2 over. So 2 times 3 is going to be, 6. 6 here. And this, so right now I've enlarged this part of the M, and I also enlarged the letter D. And you'll notice the spacing between here was only 1 square, but on the enlargement, it will be 3 squares. And that is it for the explanation of the assignment and this lesson.